Okay, today we are going to look at the linear nth term of sequences, and we are going to find the nth term. We're also going to use that nth term in questions. Whilst watching, please make sure to make notes. You need to have a pen and paper to write down anything you need to remember. Listen again. You can always pause and rewind if you need to. Be prepared to pause. If you see that pause symbol, I'm going to ask you to do an activity. It is important that you do that activity so you can test your own understanding. And finally, please try and make sure to focus. Don't have music or TV on in the background. Try and make this your sole concern for the next 15 minutes. So, linear sequences. Here we have a sequence. A sequence is just a series of numbers that have a pattern to them. In this case, 5, 8, 11, and 14 is our sequence. It continues. That's what the three little dots mean. Now, I'm going to refer a lot to terms in this. A term just means an entry in the sequence. So the very first entry, the first term, is 5. For 5, n is 1. For the second entry, or second term, we would say n is 2, and the term is 8. For the third term, n is 3, and the term is 11. The fourth term, n is 4, and the term is 14. The fifth term would be 17, the sixth term would be 20, and so on. Now I know it's going to be 17 and 20 because it's going up by 3 each time. The fact that it has a common difference tells me that this is a linear sequence, and a common difference just means that it goes up or down by the same amount each time. Okay, so it's going up by 3 here. If it went down by 3 each time, we would say the difference was -3, and it can go up or down by fractions and decimals as well. What we're going to be talking about is the nth term. So here we have the first, second, third, fourth term. The nth term, think of it as the nth term. Okay, it might be term 1,000 or term 1,000,000 or term 72. We don't know. Okay, so we want a general expression that can give us any term we wish. Okay, here we have a sequence of 5, 8, 11, 14. Now there are two methods to use here. I prefer what I call the hidden multiplication or the hidden times table, but there are two methods. I will show you both. So either method you use, you're going to start by finding the common difference. Here, from 5 to 8, we've just had this sequence, so 5 to 8, plus 3, 8 to 11 is plus 3, 11 to 14 is plus 3. Make sure you don't just check one and assume they're all the same. They might be different, and if they are, this method won't work. So if it's plus 3 every time, then we're going to use 3n in our expression for the nth term. Now what 3n really means is the 3 times table. Okay, when n is 1, 3 times 1 is 3. When n is 2, 3 times 2 is 6. When n is 3, 3 times 3 is 9, and so on. Once I've done that, I'm going to subtract those from each other. 5 take 3 is 2. 8 take 6 is 2. 11 take 9 is 2. 14 take 12 is 2. Notice as well, these are all positive again. Okay, so my expression is going to be 3n plus 2. And that definitely works, and we can check that quite easily. So if I say n is 5, 3 times 5 plus 2 is 15, plus 2, 17, which would be our fifth term. It still works. Okay. The alternative way of doing this is to still find the common difference. So you're still going to get that plus 3 every time. I'll just quickly write that back in. So we're still going to have a 3m. But instead of finding the hidden times table, we do what we call the 0th term. If this 5 is our first term, our 0th term would have been here. Something plus 3 is 5. Well, it must be positive 2. So I've put positive 2 in my nth term. Okay, and all you're doing there is finding what would have gone before it if there was a 0th term. Okay, it's imaginary, it's not really there, but you can use that method as well. Okay, here are two more examples. On the left, we'll start with the hidden times table method. We start by finding our common difference, plus 2, and plus 2. So we know it's going to be 2n. We write out our 2 times table. There we go. Subtract that from our original sequence, and you should get 5 every time. They're all positive, so it's positive 5. So 2n plus 5. Using the 0th term on the right-hand side, we still find the common difference, plus 2 as it was before. But here instead, we find the 0th term, the imaginary term that would have gone before it. It's positive 5, so plus 5. So 2n plus 5 with either method. And you can always check by substituting a number back in to the sequence to make sure it comes out right. So here are 4 questions. Have a go at them now. Use either method to find the nth term of these 4 sequences. And remember, if the numbers are going down, it is a negative something n. If it's increasing, it's a positive n. Okay, if you've had a go at that, these are what you should have got. The answers I got from these were by using plus 2 each time. So it is 2n, and the term in front would have been a 1, so plus 1. This one is going up by 3 each time, so that's your 3n, and the term in front would have been minus 2. You know, obviously you can use the other method as well, it's just quicker for marking to do this way. The bottom left one, it is increasing from minus 5 to minus 3 is still plus 2 each time. So it is 2n. The number that would have gone before is minus 7, so it is 2n minus 7. The final one, however, is decreasing. From 2 to 0, you are taking 2 away, and taking 2 and taking 2. So it is minus 2n. The number that would have gone here is 4, so it's plus 4. If you use the times table method on this, you needed to do your negative 2 times table. So it is, and this is where that method gets a little messy, minus 2, minus 4, minus 6, minus 8, and then you are subtracting. 2 take away minus 2 is 4. 0 take away minus 4 is 4. Minus 2 take away minus 6 is 4. And minus 4 take away minus 8 is also 4. Remember, minus 4 take away minus 8, those two in the middle become minus 4 plus 8. That's where the biggest mistake will come in that method. Right, so now that we know how to find the nth term, we need to know as well how to use it. Question 1 here, give the first 4 terms in sequence from 6n plus 1. All we have to do for this is say, well, when n is 1, n is 2, n is 3, and n is 4, because that will give us our first, second, third, and fourth term. When n is 1, 6 times 1 plus 1, 6 plus 1, 7. For this one, 6 times 2 plus 1, 13. 3 times 6 plus 1 is 19, and 4 times 6 plus 1 is 25. Remember your rules of BIDMAS when you're doing this, and also you can check if you've done it right, because if it's a 6n, it shouldn't be going up by 6 each time. 7 plus 6 is 13, 13 plus 6 is 19, 19 plus 6 is 25. Worked out okay. The 10th term, this will happen quite a lot. They will just say, tell us this particular term. Well, for the 10th term, n is 10. 6 times 10 plus 1 is 61. The final one, however, is a bit different, and there's 2 ways to do this. You could find a term you know, like the 61 we've just got, and gone, well, it's 61, 67, 73, 79, 85, 91, 97. Well, if that's 10, 11, 12, 13, 14, 15, 16, it's the 16th term. That is a lot of work. And if it had asked for a much bigger number, that could have taken a long time. Instead, what you can do is make an equation. We know it's 6n plus 1, and we know we're looking for the number 97, so we can make it equal to 97. Subtract 1 from both sides. 6n equals 96. How many 6s into 90? 16. Now, that is presumably a lot faster for most questions. If it asks you, say, something crazy like 697, it would have taken a lot longer to do that. That's why we solve it using an equation instead. If you want, have a quick go at this, pause it, and then I'll go through how to do it. Okay, if you've done it, the first bit, you should have just found a common difference of 4n, and depending on which method you use, either the 0th term or the hidden multiplication method, you should have got 4n minus 3. So for the first bit, 4n minus 3. Gives 2 marks here, one will be for the 4n, one will be for the minus 3. So even just finding that difference of 4 and writing 4n will be enough to get a mark. The second bit, explain why 95 will not be in a term in this sequence. Well, we could again sit there and add 4, 30 times or however many it's going to take to get there, but there is a quicker way. If we solve 4n minus 3 equals 95, if we solve that very quickly, add 3 to both sides, we're going to get 98. So n is 98 over 4. And if you do a quick bus stop on that, you will find 4s into 9 go 2, remainder 1. 4s into 18 go 4, remainder 2. And 4s into 20 go 5. When n is 24, we will get the term to be 93. When n is 25, 4 times 25 is 100, take 3 is 97. And you can work those out yourself by substituting. If 93 is in there, then it's 97, 95 can't possibly be in it. Here's another one to have a go at yourself. Use what we did before, and I'll show you the answer in a second. Okay, for this, you needed to first substitute n is 1, n is 2, n is 3, and n is 4 into the nth term of 6n plus 3. Well, 1 times 6 plus 3 is 9, 2 times 6 plus 3 is 15, 3 times 6 plus 3 is 21, and 4 times 6 plus 3 is 27. The next part, Sarah says that 1008 is a term in the sequence. Explain why she is wrong. Now, if you solved that algebraically, you could have done 6n plus 3 is 1008. So 6n equals 1005. And if I just do bus stop here, 1005, 6's into that go 1, remainder 4, 6, remainder 4, and 7.0, remainder 3, 5. And from that, you can surmise that because it's a decimal, it is not in the sequence. However, there is a much, much faster way. If you look at this, we have 6n plus 3. It doesn't matter what you put in to 6n, it will always be even. 3 is an odd. If you've got an even and an odd added together, you will always get an odd answer. And if you look at the terms we got, 9, 15, 21, 27, they're all odd. 1008 is even, and therefore cannot be in the sequence. So you would get the mark for solving it algebraically, but you could also have got the mark simply by stating that 1008 is even and all the terms will be odd. Okay, if you need to go back, you can do so now. Otherwise, have a go at the worksheet and let me know if you need any help.